Okay, one of the things that I want to tell everyone about the recordings. My iPad and or my pencil is being glitchy. I had a lot of trouble uploading Tuesday's lecture to YouTube, and I thought I'd lost it. So these are not a guarantee. These are a supplement. So I don't know what's going to happen. So I'm going to work on this weekend finding a new recording system. What has happened is with the latest iPad update, that's when Desmos started getting glitchy and I couldn't continue, like I couldn't pause recording and lots of the tools I haven't been able to use. Then it completely froze on me during a help session. So I don't know what's going to happen. Then I went back to see if Doceri had done an update, and they haven't done an update in 2 years. So I don't think they're going to update. Okay? So this weekend I'm going to try out some new systems, but just know these recordings are not guaranteed. Okay, what you want to have close by is you want to have your list of properties for logs. You want to have that list of properties for logs close by. We tend to remember the exponent ones, but we don't always remember the log ones. And you will be given your log properties during your test, but you won't be told what they are. You'll just be, so you'll have to know how to use them and when to use them and stuff like that, but you will be given those properties. Okay, what I have right here is I have the natural log of E, and E is raised to the 11th power. One of the things that I want you to remember about this is what is the base when we are using a natural log? Okay? Any idea? What's the base? 10 is the base when we are using a log that isn't written as a base. So if I had log of 14, that's when I have a base of 10, because that log doesn't have a number written for your base. But the natural log, what is the base of a natural log? E. Okay, the natural log is E. So one of the things that you want to make sure that you've got on your sheet is when we've got the natural log of E and it's raised to some power, that simplifies to whatever that power is. Okay? Now we definitely have this one where we've got log base A of A to the X power. Okay, do you see how these are the same? You've got the A. That's definitely on your sheet. Make sure this one is too. The natural log of E to the X power is X. Okay? So, if this is true, the natural log of E raised to the 11th power, what will that simplify to? 11. Okay? Now, we've got 7 raised to the log base 7 of Y. This is not used very often. Okay? But when it is used, what does it simplify to? Our bases are the same. Did you say 1 or Y?
Y.
Y, correct. It simplifies to Y. Okay? That simplifies to Y. I had to really look for a problem that had that, so we don't use that one nearly as much. Okay. Now we're going to work on solving equations. Solving equations. Okay? We're going to have logs in the equations, and we're going to have exponents in the equations. So I'm going to give you a couple of different ways to solve them. Okay? The first way, and we've already talked about this way. We did it on Tuesday or maybe last Thursday. Can we rewrite to have the same base? Okay? That is the first way, and we did that last Thursday. So that would be if I had 2 to the x equals 4, can I rewrite 4 in terms of 2? That's what that first technique is. Can we rewrite to have the same base? Because if we have the same base, our exponents are equal. Okay? The opposite of that is also true. Can we rewrite to have the same log base? Okay, so let me tell you what that would look like. If I have log of x, or log base x of a, equal to log base x of b, what do I know about a and b? They're equal. Okay, so 1 and 2 are similar. One's just with exponents and one's with logs. Now, for both of those, you have to have that for both sides. Okay, so you've got to have a log on both sides, and you've got to have the same base raised to a power on both sides. If it's not on both sides, you can't do it. Which leads us to our third way that we can solve problems, and the way that we are going to be able to solve this problem is, can I rewrite a log problem as an exponent? And that's what we're going to do with this problem right here. Can I rewrite a log as an exponent? Okay? And then the fourth way is to take the log of both sides. And one day, I'm going to learn to write smaller. Okay? So these are 4 techniques that we're going to use today to solve equations in this chapter. Okay? Rewrite to have the same base, which we've already done. Rewrite to have the same log base, which we will do. Rewrite a log as an exponent, which we're going to do right now. And then the fourth is take the log of both sides. Okay? So keep this list handy. And make sure you have it in front of you when you're doing homework problems. Okay? So this is a situation where we are going to take the log and we're going to rewrite it as an exponent. That's something that you always want to look at when you've got a log on just one side. Okay? So do you see how I have a log on just one side? So kind of the thing that we look for here is a log on one side. That's what we look for, a log on one side. So I'm going to rewrite this as an exponent. What is my base? 3. And this is the definition of an exponent. What am I raising 3 to? -2. Okay, that's the definition of a log. I said definition of an exponent, but it's the definition of a log. Okay, and what is it equal to? Y. Okay, so we want to be able to go back and forth between logs and exponents continually. And we did a lot of that on Tuesday. Today's Thursday. Tuesday. We did a lot of that on Tuesday. Okay, so 3 to the -2 is 1 over 3 squared. And 1 over 3 squared is what? So our answer here is 1/9. Okay? Can I go off this screen? No. It's okay. Am I good? Okay. Here I I've got log base 25 of 1/5 equals x. I have a log on only one side. So I am going to rewrite this as an exponent. What is my base in this log? 25. So that's going to be the base in my exponent. What is the 25 being raised to? X. And then what does it equal? 1/5. Okay? Now, what I'm going to do first here is I'm going to rewrite 25 as 5 squared. Okay? So I'm going to take 25 and I'm going to rewrite that as 5 squared. And 5 squared is raised to what power? X. Okay? Can I rewrite 1/5 as 5 to the negative 1 power? Yes, I can. 5 to the second power raised to the x power means I have to multiply that 2 and that x. So I'm going to have 5 to the 2x equals 5 to the negative 1. Okay? I have the same base. So 2x equals negative 1. Good. And then I divide by 2. So x is equal to negative 1/2. Okay? Say that one more time. I'm dividing by 2 right here from this. Are you wondering where I got it from here? Oh, okay. So you're good? Okay. Is it okay if I go to the next screen? Okay. Now here, I am going to rewrite this as an exponent, but I need to deal with that 2 first. The operation that's happening between the 2 and the log is multiplication. So I have 2 times log base 4 of z equals 6. Before I can rewrite this, I need to get rid of that 2. How do I get rid of the 2? Divide. Okay, so then I'm left with log base 4 of z equals 3. Can I rewrite that? Can I rewrite that as an exponent? I can. What's my base? What's it raised to? And what does it equal? Good. Okay, and what is 4 to the third power? 64. Good. Okay. So those problems are where we took a log and we rewrote it as an exponent. Okay? This next problem, is it okay if I go to the next one? This next problem is where I have a log on both sides, and my log on both sides has the same base. So this is equivalent to log base x of a equals log base x of b. Therefore, a is equal to b. So now I can set x squared plus x equal to 2x plus 6. Okay, and do you know how to solve that? You do know how to solve that even if you've forgotten. Okay? You're going to set equal to 0 and then what?
So if you take out the bases well, is they the same?
Yes, you take out the base as well because they're the same. You do.
If they're different, then what do you do?
If they're different, you can't use this property. You would have to find another way to solve if the base is different. you won't see that. Okay? You're setting equal to 0 and solving. Okay, so we are subtracting 2x from both sides. So I have x squared minus 2x. No, negative 1x, I'm sorry. Equals 6. What's my next step? Good. Subtract 6. So I have x squared minus 1x minus 6 equals 0. Okay. This factors to x minus 3 and x plus 2. X minus 3 equals 0. X plus 2 equals 0. We get positive 3 and we get negative 3. Now, I do not want you to get in the habit of throwing the negative 2 out just because it's negative. But when you have a negative, you must check it. You must check it. So, what I want you to do right now is I want you to take the log of negative 4 on your calculator. Take the log of negative 4 on your calculator. What'd you get? What's the log of negative 4? Error. Undefined. Domain error. Okay. The log of negative 4 is not real. Do you know how we talked about the square root of negative 1? And it fell into that whole other area of imaginary numbers? Okay, that's where these hang out. Okay, it's not real. The log of negative 4 is not real. So what we have to make sure is that we don't get a negative number here. Okay, so plug negative 2 in there and what do you get? Negative 2 squared plus negative 2. What do you get? Negative 2 squared plus negative 2. You get positive 2. Okay? I can take the log of a positive 2, so I'm okay. Now, on the other side, 2 times negative 2 plus 6. What do I get? 2. Okay? So both of these are okay. Sometimes you're going to have to throw that negative number out, and sometimes you don't. You only throw it out if it makes this negative. That's what can't be negative. The negative number is okay, as long as it doesn't make that index negative. Okay? Okay. Now, I told you it took me a while to find a problem with this. I have e raised to the power of a natural log of x. What happens to the e in the natural log? Do they have the same base? Okay, this is the same thing as x raised to the log that's what we dealt with right here. Okay? Except we have e. So do you see how the 7 and the 7 are the same? That's what we're dealing with here. What's the base of the natural log? E. So what happens to these? They cancel. I'm left with x. So I have x plus x squared plus 3 equals 9x minus 9. Do you know how to solve that? Yes. You factor, or first you have to set equal to 0. And then factor and solve. Okay? Do that right now. How are we doing? Did you guys get this far? I subtracted 9x from both sides, then I added 9 to both sides. You should have ended up with x squared minus 8x plus 12 equals 0. You've got x minus 6 and x minus 2. Now, when I set these equal to 0, they are both positive. Okay? They are both positive. So that means the x that I put in that natural log up there is going to be positive. And it's okay. Okay? So you always want to be thinking about, if I get a negative number, I need to go back and check it to make sure I can do it. Okay. Now, can I go off the screen? Okay, go ahead. Because the base of a natural log is e. Okay? So we talked about if I've got 7 raised to the log of base 7 is x. These are the same base. This is a 7 and this is a 7. Okay? And all the time, the base of a natural log is e. Okay, so if I've got e raised to the natural log of some number, you can think about that as an e right there. Okay, just to help your brain. You don't. That's not what I mean. The natural log's base is e, and if writing that e in right there helps your brain, go ahead and do it. Okay, good question. Okay. Solving equations, which we're doing today, and rewriting as sums and differences of logarithms, and writing as a single logarithm, are where students struggle the most. I want you to take 3 minutes And I want you to do these. The first one, you are breaking it apart to write it as sums and differences. The second one, you are putting them together. They are the properties that we talked about on Tuesday. They're the properties that we talked about on Tuesday. Okay? So go ahead and do those right now. Okay, so this is where you need to practice. These and equations. The graphs are not on your test. When are you responsible for graphing? When? The project, okay? So the graphs that we talked about aren't, they're important, but they're not on the test. Okay, so we are going to get started with this one. We are breaking this apart, and I want you to be sure that you look at it piece by piece. So I have log base A of x squared times y to the fifth. When I am multiplying variables together, I can rewrite that with the same base as addition of two separate logs. Okay, so that is the addition of two separate logs. Okay? Now, I'm not going to deal with my exponent yet. I want to deal with the multiplication and the division. What do I do with the the z? What do I do with the z? Subtract. Good. I subtract log base A of z to the fourth power. Okay? What do I do with w squared? Okay, I have one subtraction and I have one add. Tell me why I subtract.
Because it's still dividing. It's still in the denominator. You're still dividing.
Good. If it's in the denominator, you still divide it. I understand, though, why you say multiply or add, because it's being multiplied to the z. So it is division, and let's talk a minute as to why. Okay, let's talk a minute as to why. If I've got x squared, y to the fifth, and I want to rewrite z to the fourth, but I want to put it in the numerator, how would I write that? It would be the negative fourth. Good. It would be the negative fourth. Okay? If I want to move w to the numerator, what power would it be written to? Negative 2. That is why. That right there is why. Okay? Now, what's my next step here? What do I do with those exponents? Where do they move to? The front. Okay, that's the power rule. So I have 2 log base a of x plus 5 log base a of y minus 4 log base a of z minus 2 log base a of w. Okay? Can I go any further? I can't go any further on this one. Okay?
So if they were like, if it was like, say if it was log a x squared and log x to the fifth, then could we combine those?
I would combine it before you broke it down into logs. I would combine it in the numerator beforehand. But that's a great question. Typically what you may see is something like this. 5 log a of a. Do you see that? What does log base a of a simplify to? It would be just 5 because log base a of a simplifies to 1. Okay? So that's what simplifying would look like. It wouldn't really necessarily look like what you were talking about. Okay? Okay. I want to deal with the exponent first. So I am going to take this exponent and I am going to put it with the variable. I don't have an exponent here. So I'm going to have log base b of x to the what? Fifth. Minus log base b of y plus log base b of z to the 1/4. Okay, z to the 1/4. Now I'm going to rewrite it as a single log. I have log base b of x to the 5th. Okay? Now, what does this minus mean for that y? It's in the denominator. Excellent. So I have y in the denominator. Okay? What does this plus mean for z to the 1/4? Numerator. Okay? That is 100% correct. I will accept this without any problem whatsoever. Okay? What does z to the 1/4 mean? What does z to the 1/4 mean? A rational exponent means that we have to have a radical. The z to the first power is inside the radical, and this is the root. Okay, so if you wanted to rewrite that way, you would be fine. Log base b, x to the 5th, the 4th root of z. Okay, both of those are correct. Both of those are correct. Okay, are you ready to solve some more equations? Okay. Can I move off this screen? Is it okay to move off this screen? Okay. We talked about 4 different ways that we can solve equations. What's the first one? Good. Rewrite an exponent with the same base. Okay, what's the next way? Okay, rewrite to have same log base. Okay, in both of those situations, if I can rewrite it to have the same exponent base, or I can rewrite it to have the same log base, then I can use the property that says the exponents are equal or the index is equal. So I can just remove that. Okay? But I can't always do that. Look at this problem right here. I've only got a log on one side. So what's my third way? Good. Rewrite, and that's what we're going to have to do with this one. Rewrite a log as an exponent. And my last one is what? Take the log of each side. And we will have to do that as well. Okay. This one, the natural log of x equals 2. I've only got a natural log on one side. I don't have it on both sides. What is the base of a natural log? E. Okay, so if I rewrite this as an exponent, I have e to what power? Second power, and it's equal to x. Okay? Use e on your calculator and raise it to the second power. On your calculator, do e to the second power. Seven. I need somebody to tell me. 7.389. Okay. Now, 7.389 is an approximate. We have rounded that. E goes on forever. It is a non-repeating, non-terminating decimal, just like pi. Okay? It's irrational. So when we take our calculator and we plug e and we do something with e, we get an approximate. So how do I write that an answer is an approximate? How do I write that? Squiggly lines. Good. Squiggly lines. Okay, so I have squiggly and squiggly. That means that that is an approximate. That means that is an approximate. It's the same idea as the square root of 5 and taking the square root of 5 on your calculator. You have to round the square root of 5 on your calculator. The square root of 5 is an exact. When you get the decimal on your calculator, that's an approximate. Okay, so we're going to be talking some about exact and approximates. Okay? Can I go to the next screen? Here I have log base 6 of 3x plus 14 minus log base 6 of 5 equals log base 6 of 2x. Okay? I need to use my log properties to rewrite that left side as only one log. Okay, so when I have things being subtracted, what does that mean? I am dividing. Good, so I have log base 6, and then I have 3x plus 14 in the numerator. What do I have in the denominator? 5. That's equal to log base 6 of 2x. Now, I am allowed to pull the logs out only because I have the logs on both sides. If I didn't have the logs on both sides, I'd have to rewrite it as an exponent. But in this situation, I have the logs on both sides, so I can remove them. It's this property right here. Log base x of a equals log base x of b, a equal to b. That's the property that I'm using. Okay? So I can rewrite this as 3x plus 14 over 5 equals 2x. Okay? Now, how do I solve this? Multiply both sides by 5. Okay? I have 3x plus 14 equals 10x. I subtract 3x from both sides. So I have 14 equals 7x. What's my next step? Divide by 7. Okay? I did not get a negative number. I did not get a negative number, but if I did, I would need to go back and make sure that didn't make my index negative. Okay, that's that number that we're taking the log of. Okay? Can I go to the next screen? Yes? Okay. Here I have log of 5x plus log of x minus 1 equals 2. I do not have a log on both sides. So I need to rewrite this as a single log. What is the base to these logs? 10. Anytime you do not have a base written there and it's log, your base is 10. That's what that means. Okay? So I have log base 10. You can write that 10 right there if you want to. What's happening to the 5x and the x minus 1? They're being multiplied. Okay? So I have 5x times x minus 1, and that's equal to 2. Now I have a single log on one side equal to something without a log on the other side. So what do I have to do? Which method? Yes, I'm going to rewrite this as an exponent. Now, it's dangerous when I have log base 10 because we forget about the 10. Okay? So don't hesitate to write that 10 in because my base here is 10 and I have to square that. Okay? My base is 10. I'm raising it to the second power, and what does it equal? 5x times x minus 1. Okay? And we know how to solve that. What's 10 squared? Good. And then I have 5x squared minus 5x. I can go ahead and set that equal to 0, but what do you notice about all the numbers? They're all divisible by 5, and I highly recommend that you go ahead and take that 5 out. Okay, so I'm going to divide everything by 5. So I have 0 equals x squared minus x minus 20. When I factor, I get x minus 5 and x plus 4. Negative 5 times 4 is negative 20. Negative 5 plus 4 is negative 1. I set each one equal to 0. So I get x equals 5 and x equals negative 4. What do I need to do with that negative 4? I need to check it. I need to make sure, since I have a negative number, that when I plug it in, these aren't negative. The negative number is okay. It's the index that can't be negative. What is 5 times negative 4? Negative 20. So what do I have to do? Can I keep it? No, I got to throw it out. When I plugged it into the other one, I would have got negative 5, so it wouldn't have worked with either one. Okay? So I would have to throw this out, and my only answer is x equals 5. Is it okay if I move off this screen? Okay. Okay. 2 to the x power equals 14. What we would like to do in this situation, when I've got 2 to the x power equals 14, I would like to be able to rewrite 14 with 2 as an exponent. 2 to the third, 2 to the fourth. That's what I would like to be able to do. Can I do it? Can I rewrite 14 in terms of 2? No. 2 to the first is 2. What's 2 squared? 2 to the third. 8. 2 to the fourth. 2 times 2 times 2 times 2. 16 times 2 more. 32. So I can't. Okay? When you cannot rewrite this, when I cannot rewrite, can't rewrite with a base of 2. When that happens, that's when you take the log of both sides. Okay? That's when you take the log of both sides. Okay? That's when you take the log of both sides. When you can't rewrite to have the same base. So what I have here is I have the log of 2 to the x power equals the log of 14. Okay? Now, log 14 is a number. We don't know what that number is, but it's a number. Okay? Log of 2 is a number. Okay? Where do I take that x? Where do I put that x? The power rule in front. Okay, so I have x times log of 2 equals log of 14. The operation that is happening in between that x and that log of 2 is multiplication. So how do I get rid of log of 2? Divide. Good. That's exactly right. I divide. Okay? So my answer is x equals log of 14 over log of 2. That is not log of 7. That does not simplify the log of 7. Order of operations means that I have to take the log of 14 and the log of 2 first before I can do that division. Okay? That's because logs fall in the order of operations at the same level as exponents. So do not divide that 14 and 2. That's not what you can do. Okay? Now, this right here is an exact answer. It's exact. So if you put on your test log 14 over log 2, you would be correct. It is an exact answer. Now, grab those calculators. You want to start getting used to dealing with this on your calculator. Okay? I am going to put the numerator in parentheses, and I am going to put the denominator in parentheses before I put this in my calculator. It's a good habit to get into. Parentheses, log, and as soon as you hit log, what shows up? Good. So I'm going to have log of 14. Now, I have to close this parentheses, then I have to close the numerator. Whoa. Yeah, I don't know what happened there. Okay? There's my numerator. You're going to have a double parentheses. What does the fraction bar mean? Good. Then I have log. As soon as I hit log, I get a parenthesis. I close it with the 2. And then I close my denominator. Okay, so be very careful with those. When you do that, you should get 3.807. Okay? This is approximate. It's not exact. Now I want you to do 2 raised to the power of 3.807. Oh, yes, Shay?
So, for log 14, I did the double parentheses, and then when I did it for the 2, it didn't work, and then I deleted the last parentheses, and then it worked. So the double parentheses doesn't work on my calculator.
Okay, it would depend on what kind of calculator that is. Yeah.
I was playing around with it because
Did you put a parentheses on the first part? Like, did you put this parenthesis in?
Yes.
Because if you had a double parenthesis and you didn't put that parenthesis in, it wouldn't work. So try that. But different calculators do different things. Okay, do 2 to the 3.807. What did you get?
13.9965.
Yeah, 13.9965, and it keeps going. Okay? Is that approximately 14? Yes. The reason that you don't get 14 equals 14 is because we rounded the 3.807. Okay? So that's an approximate. Okay. Are we ready to try the next one? Did it work, Shay, when you did it the second time? Good. Okay, perfect. Can I go to the next screen? Okay. If I asked you to solve the problem, x plus 3 minus 8 equaled negative 9. Let's not do negative 9. Let's do negative 7. Okay, if I asked you to solve that problem, you see a square root in there, and you know that anytime we have a square root, to undo the square root, we've got to square it. But I wouldn't just square it first. What would I have to do before I could square both sides? I'd have to add 8 to both sides. Okay, so before I could square anything, I would have to add 8 to both sides. Then I could square both sides and solve the rest of the problem. Okay? Now, if I had the absolute value of x minus 7 minus 3 equals 2, before I could deal with the absolute value, what would I have to do? I'd have to add 3 to both sides. I've got to get that square root by itself. before I can square. I've got to get that absolute value by itself before I can deal with the absolute value. The same is true here. I have e to the x power plus 5. I can't deal with that e to the x until I deal with the 5. How do I get rid of the 5? Good. So I'm going to subtract 5. And I'm left with e to the x power equals 55. Now, that e is showing up again. The e is showing up again. What log has a relationship with e? Which log? Natural log. Anytime you have an e in an equation, that should indicate to you that you need to take the natural log. Okay? So we are going to take the natural log of both sides. Okay? I'm taking the natural log of both sides. The natural log of e, what happens to that? Cancels. So I'm just left with x. So x equals the natural log of 55. Okay? Give me an approximation for that. Do that on your calculator. Natural log of 55.
4.006.
Good. Okay? This is exact. This is approximate. Okay? Exact and approximate. Okay. Are we ready for the intense one? We ready? It's intense. Okay. Can I move off this screen? Good? Okay. So, I have a 2, and I am multiplying that 2 times 3 raised to a power of 2t minus 5. Then I have a minus 4 outside that parentheses, and it's equal to 11. Okay. The first thing that I'm going to do is I'm going to get rid of that 4. The way I get rid of negative 4 is I add 4 to both sides. Okay? So then I'm going to have 2 times 3, 2t minus 5, equals 15. Now, I can also get rid of that 2. How do I get rid of that 2? Divide. Okay. I need to write way smaller. So I have 3 raised to the 2t minus 5. That is equal to 15 over 2. Okay. Now, I can't rewrite 15 over 2 in terms of 3. 3 to no power is going to give me 15 over 2. So I have to take the log of both sides. That's what I have to do here is take the log of both sides. Okay? And I'm going to take log because there's no e in this. If there was an e, I would take the natural log. But there's no e, so I'm just going to take the log. So I have log of 3 raised to the power of 2t minus 5 equals the log of 15 over 2. Okay? 2t minus 5 is my exponent. Where does the power rule tell me to take that? To the front. This is where students make mistakes on this if they're going to make a mistake. It's right here. So I'm going to put a star right here because this is where students make their mistakes. Okay? This 2t minus 5 goes in front of my log. Log 3 is a number. It's just a number. So what do I have to do with that log 3? And,
15.
nope, just you've got to distribute it.
Okay.
So you're going to multiply it times the 2t, and you're going to multiply it times the -5. That's where students make mistakes, right there. You have to distribute log 3. Okay? That's what you have to do right there, is you've got to distribute it. So I am going to have 2t times log 3. Then I'm going to have -5 times log 3 equals log over 15 over 2. And I'm not even going to try to write small enough to get this all on one page. So let me know when I can move to the next screen. And I'll rewrite that last step. Okay, is it okay for me to go? Okay, so my last step is 2t times log 3 minus 5 log 3 equals log 15 over 2. Okay. What am I solving for? What am I trying to isolate for? What variable? T. Okay? So I need to start getting things away from the t. If I had 3x minus 4 equals 15, what would I do next in that 3x minus 4 equals 15? Add 4 to both sides. Okay? That's the same thing I do here. I'm going to add that to both sides because it's negative. So I'm going to say plus 5 log 3 plus 5 log 3. Okay? So now I have 2t times log 3 equals log 15 over 2 plus 5 log 3. Okay. My 2 and my log 3 are numbers. That's all they are numbers. And they are being multiplied times t. How do I undo multiplication? Divide. That's what I'm going to divide by. So I am going to divide by 2 and the log 3. So I'm dividing both sides by this. Now, on the left, I have my t isolated. And on the right, it looks very complicating, but what I have on the right are numbers. They are all numbers.
Did you cancel out the log 3?
I cannot cancel out the log 3s. That's a good question, though. To cancel out the log 3, I would have to factor out a log 3. And I can't do that.
Did you divide 5 into 2 because they have the same base?
You cannot do that either. Because you've got to take the log of it first. Because the order of operations with logs fall at the same level as exponents. So we have to deal with those logs first before we do anything else. Yeah. And I know our brain wants to do all sorts of stuff with that, but we can't. We've got to deal with the logs first. So, this right here is an exact answer. It's a very long answer, but it is your exact answer. Okay? So if you leave that on the test, you're good. I want us to talk about keystrokes on your calculator. Okay, yeah. So these are my keystrokes. I am going to put the numerator in parentheses. I'm going to put the numerator and I'm going to put the denominator in parentheses. So my keystrokes, I start with a parenthesis. Then I have log. As soon as I hit log, I get a parenthesis. And I have 15 over 2, parenthesis. And then I close the parenthesis. Nope, I don't close. Sorry. Okay? So what I've written down right here is this right here. Now I am adding that to 5 times log of 3. I have closed the parenthesis for the 3. Now I need to close the parenthesis for all of it. Okay? Then I divide. I'm going to put my denominator in parentheses. Okay. Sometimes you've got to try this a couple of times. Anybody have an answer for me? That is not what I got.
I got 3.41.
That's it. You'll get it the next time, I promise. 3.417, and that's an approximate answer. It's approximate. Those calculator keystrokes are brutal.
So, if we only choose, if we get it the first time and this second time, how do we know what the answer is?
Your exact answer is your logs.
Okay.
Okay? Your approximate answer is the 3.417.
So, what if we get the exact one right, but the approximate one?
Then I'll just take a point. It won't be much. I may not even take a point because you got the exact one right. Because you would get full credit if you just had the exact one right. I haven't decided yet. Is that fair? Okay. I would encourage you to try to get your homework done this weekend so we can practice next week. Okay? That right there is as bad as it gets. There's no new information in chapter 4. Okay. Have a good day, guys. Have a good weekend.